Okay, let's start class. Today's topic is purpose of the components in CPU. This is very important topic because all these components they play a very important role in fetch, decode, in execute cycle, right? So you need to understand the function of every individual component. So let's start. So earlier I told you about this computer takes the data through different input devices, right? So the data can be a text base through keyboard, a microphone, it takes sound or mouse, etc. Okay. Then this data that is received by the central processing unit, CPU. CPU, that is responsible for the processing and the execution of the data. CPU is directly interconnected. Interconnected, you can say, or directly is in connectivity with the memory where it reads the data or write the data. Reads the data or write the data. Clear? And after processing, it generates eventually an output that could be on your LCD, or if it's a sound, then it can be a speaker. Is that clear? Okay, let's move on. So now you need to understand. Let me draw. Yes, that's a better way. Let me draw a diagram to better understand the individual components, internal components of the CPU. So that is the internal structure of CPU. Okay, so we have different types of register, program counter. I'll tell you one by one in details, and you need to get ready to copy the data on your copies or notes, whatever. So it's a MAR register. Just a second, let me make it more clear. MAR register. Then we have MDR register. And we have control unit, that is very important part of the computer. Then we have ALU, and we have accumulator. ACC means accumulator, right? So let me choose a different pen. This one is better. Control unit, it controls all the components, all the activities of your computer. So it means control unit is controlling all the registers, right? By sending different types of data or control signals to different registers, right? So white actually represent control signals through buses, right? So this is your internal structure of CPU. Then we have address bus. Here, this is your random access memory or main memory. It has addresses and it has data. That is your memory or random access memory. Okay. So it has different addresses inside the memory. It has unique locations. So let's say this is 0 0 0 0 0 0 0 1 0 0 0 1 1 etc. Right? So it has different types of data or instruction inside it. So address bus, that is a unidirectional bus. I'll tell you in details. Let me complete this diagram first. So that is your data bus. Data bus means it's a bidirectional bus. You can see the arrow sign. It's a bidirectional, and this is your control bus. Okay. So, as I told you about that, I'll tell you about the individual component of the CPU. Then, so you should, so let me start. Uh, Control unit. Control unit, please, you need to write down on your copies control unit, then I'll explain it as well. Control unit. Control unit, it's a main component of the CPU. It coordinates, it coordinates all the CPU activities, all the CPU activities. Number two, it coordinates and coordinates and communicates, communicates with all parts of the CPU. And the third main important part is that is responsible. It is responsible for sending, read and write requests to main memory or RAM through control bus. Control bus. So CPU, this part, control unit is responsible for all the CPU activities, right? So that is also responsible for the communication between different parts of the CPU. So as you know, that CPU control unit जो है, that is coordinating, that is transmitting, that is interconnected with all the parts of the CPU, right? With all the register as well, right? So it communicates and coordinates the activities of the CPU with other parts, right? And CU control unit is also responsible for sending read and write request from the main memory through control bus. Acha, what does it mean read and write? Sometimes computer, beta, you need to understand this thing, right? Read the data and write the data. Write the data means to save the data in RAM. And you know that RAM, that is a volatile memory, right? Volatile or temporary memory. Okay. Read the data to get the data from the RAM back to the processor, and it processes the data and eventually it displays the data on your output device. Clear? So we are done with the control unit. Then let's discuss what is the first register. It's a program counter register. Let's discuss this program counter register. You know, program counter register, counter register, it holds the address of next instruction, ad, holds the address of next instruction to be executed, right? And sometimes, if you can see this in diagram, program counter register, for example, it is holding 0000. That is the address of next instruction, right? So that is directly in communication in relation with the MAR, right? So it means this address, which is 0000, that is transmitted or copied to the MAR register, memory address register, right? So, but right now we are discussing program counter register. So it holds the address of next instruction to be executed, and PC sends that data or address to the MAR register. Clear? Now the second register is MAR, which means memory address register. Oh, it's memory address register, MAR, and this is PC. Okay, so MAR holds the address of memory location. There is a difference. It holds the address of memory location. It means कि ये जो एड्रेस है which is in the MAR, it knows where is the location of this address in the memory, right? Is that clear? It knows where the data is to be fetched or written in the memory. Clear? So, so do not confuse these two concepts. Program counter, beta, it holds the address of next instruction, whereas after transmitting or copied this address to MAR, now MAR knows ये जो address आया है which is received from program counter, which is address is this one 0000. Now MAR knows the address, where is that address in the memory location, and where is that address? This one he is talking about. Now the clear है? So what is the data or instruction against that address, that is 010101, right? चलें अभी आगे हम चलते हैं. So the next register is memory data register. MDR. Is that clear? So MDR, sometimes you can find out in different places. This MDR register is also represented as MBR. MBR means memory buffer register, right? तो मुझे लिखने दें memory buffer register. But normally we call it memory data register, so you don't need to worry, right? So what is the function of the memory data register? This register is used to temporarily store data that is read from or written into memory, main memory or RAM. Clear? Any question? Okay. The next register is CIR register, current instruction register. CIR. It means it holds the current instruction being executed, right? Okay, you need to notice one thing here. Current instruction register, I said, holds the current instruction. By the way, it's not in your syllabus. Instruction is further split into the opcode and operand, right? Opcode and operand, this is in AS, but you have to remember this, that instruction is split into the two parts, that is opcode. Opcode mean operation code. And what are these code? Operation codes, for example, load, jump, store, etc. Right? Operand means it can be an address or it can be a value, right? So current instruction register, it holds the current instruction being executed. This is uh, w- it is the point where fetch cycles complete. So no, don't confuse it, right? So let's talk about fetch, decode, execute cycle in the next lecture, right? In the next video. So this is the CIR register. You just need to remember the function of the CIR. And sorry. So we are done with the PC. Then we have done MAR up till now. Now I'm repeating program counter register. It has the address which is 0000. This address is transmitted or copied into the MAR. So it means now MAR has also this address. Now MAR knows where is the address of this location, this address. So it knows, it sends this address through address bus. And you know, address bus, this is a unidirectional bus. Unidirectional bus means it carries only the address only one way. So address bus is responsible to carry out the addresses of the memory location, right? So the size of the address bus can be 8-bit, it can be 16, it can be 32, etc. In real life, that is more than 8 bits, right? Eight, the address can be 16-bit and the data can be 16-bit as well, right? So address bus, so that is unidirectional. It only takes the data only one way. That's why we call it unidirectional bus, right? Now, what happens after that? Against that address, this is the data or instruction that is copied or travel down to data bus through data bus, which is bidirectional bus. And this data is copied into the MDR. What is that data? 0101. Where is that data? This one, instruction or data. So this data is copied into the MDR. Moreover, this one, where is the CIR? I forgot this. Oh, come on. Just a second. Let me, this here is the CIR register, right? CIR. Okay. So this data 0101 are instruction that is copied into the CIR for the execution or decoding so that CPU can understand the data, right? At CIR stage, the instruction that is split into the opcode and operand. Earlier I told you about that, right? So up till now, we are done with the individual register, their functions, and opcode, operand, CIR, MDR, MBR. Now it's time to, so we are done with the address bus. Data bus, it's a bidirectional bus. So the data can be transferred from RAM to CPU, CPU to RAM, etc. And control bus, that is control unit sends the signals or indicate the RAM. The operation is to be done like the read operation or the write operation. You now know it is responsible for the transmission, for the transmission of control signals and coordination and for the communication purposes to all the parts of the CPU. Is that clear? So I hope that you better understood the concept of the individual component of the CPU. Now it makes a better understanding of the fetch, decode, execute cycle in the coming videos. So that's all for today. So I'll upload a new video about fetch, decode, execute cycle and what is the uh, version of the John von Neumann about the computer. So we'll discuss about this thing in the next video. So that's it. I hope you understand. Thank you. Bye bye.